Hello everybody, hope all of you are doing wonderful. We are diving into something that often frustrates data engineers and analysts alike. That is data skew. If you have ever run a Spark job, especially in Databricks using PySpark, or tried to work with large data sets, chances are you have encountered this pesky issue. And trust me, it's not just you. It's one of the most common performance bottlenecks in distributed computing. So what exactly is data skew and how can you tackle it efficiently? Let me break it down in a simple way, easy to understand way with real world examples and tips you can apply today. Let's start by understanding what data skew is. So imagine you have a data set you need to process and you divided it into multiple partitions. So each part can be processed by a different node in your cluster. Sounds good, right? But what happens when one of those partitions has a lot more data than the others? That's right, that partition becomes a bottleneck while the other node sit idle. This imbalance is what we call data skew. Okay, so here is a real world analogy. Picture a group of people trying to lift several boxes. If everyone has just one box and works together, things go smoothly, right? But if one person gets stuck with a box that weighs 10 times more than the other, they will slow everything down, right? Data skew is like that. One overloaded partition slows down the entire job. Now let's look at some of the causes of data skew. This often happens when data is distributed unevenly. For example, suppose you are working with sales data across different regions. If most of your sales come from a specific region, like North America, while other regions have way less data, you end up with uneven partitions. So how do we solve this? There are several techniques and I will walk you through a few of them. First up is like salting your keys. When you are aggregating or joining on a specific key, adding a random salt value to your key helps spread the data more evenly across partitions. Essentially, you are fooling the system into creating more evenly distributed keys, reducing the likelihood of data peeling up in one place. Another approach is to repartition your data based on more balanced keys. In PySpark, you can use repartition parenthesis function to manually set the number of partitions or use a key that spreads the data more evenly. For instance, instead of using reason as the key, you might use a combination of reason and months. And don't forget, sometimes simply increasing the number of partitions overall can help. Though it's important to strike a balance here, too many partitions can lead to overhead, while too few might not resolve this skew. So in summary, data skew happens when one partition gets stuck with more data than the others. It can be a major performance issue. But by using techniques like salting key, repartitioning intelligently, or choosing better keys, you can help mitigate this problem. If you learned something new today, don't forget to hit the like button and subscribe for more content like this. Also, if you have faced data skew in your project, drop a comment below. I would love to hear how you dealt with it or if you have any questions. Thank you so much for watching and I will see you all in the next video. Stay curious and keep coding.